Hello. Today we're going to be presenting about electric vehicle trends in Washington. I'm Ryan.
I'm Mohammed.
I'm Ayman.
Miguel.
Next. So for our dataset selection, we chose a dataset that contains a number of electric vehicles and hybrids in the state of Washington. And the dataset contains 17 columns and 217K rows. Next. So here we have the fields, and the ones I have in bold are the ones that we actually used. Uh, The ones to take note of are just like legislative district. That's just the district where the vehicle owner, all the location variables, like all these fields, that's where the vehicle owner resides in. And the vehicle location, that's just the coordinates of the zip zip code, which is just, well, we have it here as postal code, but it's just the geographic coordinates of the postal code, the center. And for the electrical vehicle details, we have the model year, make, model, and the electrical vehicle type, which is just either hybrid or a battery type. In addition, we have the clean alternative fuel vehicle eligibility. It's the electrical vehicle is just either eligible or not. And this is just for tax reductions, like if it's eligible or not. And finally, we have the electric range and base MSRP. So for identification, we didn't really use these fields because they're just unique ID numbers for the for each row. Next. So for pre-processing, first off, there were a lot of inconsistencies. So, one of the major ones was that there were more than 17 columns, and this was due to the electric utility column, which actually had uh, this regex that would where it included an extra comma, and that made pre-processing kind of hard because we use the comma as the delimiter in a CSV file. So we just had to replace this regex with a blank string, and that fixed the problem. For clean alternative fuel vehicle, we just standardized this by replacing any eligibility with eligible and any instance of ineligibility with ineligible. For electric vehicle type, we just standardized this one by labeling them hybrid for hybrid cars and battery for battery electric cars. Next. In addition to standardized county and city, we just capitalized all these fields so uh, they would all be standardized. And for vehicle location, we just separated the field into latitude and longitude. Now, for missing values, electric range was the most troublesome because this had a lot of zero values and missing values. There were a total of 124,101 missing values. And we just filled in these missing values by using the average electric range of electric vehicles with the same model and make. Now, for rows with significant missing values, we just remove this from the data set. Next. Now, for outliers, since our project is centered around electrical vehicle trends in Washington State, there were actually entries or rows where the state was outside of Washington. So since we're trying to find trends in Washington State, we just removed any uh, row that had a different uh, uh, that was not Washington for the state column. And for finally, we just removed columns that we didn't think were important, such as the ID numbers and categorical data that are listed right here. And any columns or yeah, any column that had significant missing values, which was just the base MSRP. Next. Here we have some statistics just for hybrid and battery cars. The electric range, we have the mean, standard deviation, min, all that stuff. The standard deviation for battery is quite high. Uh, on the left, we just have a box plot of the electric ranges for both hybrids and batteries. Next.
All right, thank you, Ryan. So as you guys saw, we have a lot of pre-processing that we did, and there was a lot of shell scripts that we had to write. And we had to do unit testing on all these shell scripts. And you saw some of the examples that Ryan was talking about, and I'm not going to obviously go through all 13 or however many there were. And so I just wanted to give a few in this slideshow for the presentation. Obviously, we had these tests run on bigger samples, but these smaller samples are just for the slides so they can fit well. So one example is the address standardization that Ryan was talking about. So we had to obviously make sure that everything looks the same. So everything's either all capitalized or all lowercase. Um, and so we had this script that takes the inputs and for need as the column that was required, but capitalized. And so here's the input, VIN number, county, city, state. And if you chose the third column, it would just capitalize all the cities. So here in the output, Seattle, Redmond, Tacoma, Everett, they're all capitalized. One more example I wanted to go over for the unit testing is the Washington exclusive. Ryan also talked about this one, where he was saying that we want to get rid of any states that aren't Washington, because Washington is what we're focused on in our data set. And so here you can see in the input, we took in Seattle, Washington, Redmond, Washington, Tacoma, California, and Everett, Washington. Now we want to get rid of Tacoma, California. I have this shell script on the right, and when run on this input file, it would output only the Washington results, so only the cars that are from Washington. Now the goals for our project, which were in our original presentation, and they proceed here, are based on popularity. What is the best choice of electric vehicle? So what's the most popular? And what type of EV is preferred? Is it the plug-in hybrid or is it the battery electric vehicle? And lastly, and these are what we're going to be going over for the rest of the slides. Based on occurrence, which cities, countries, and legislative districts are most likely to have the best EV charging infrastructure and policies? Are they the bigger cities, the smaller cities? What types of cities are we typically going to see with big EV charging? And now I'd like to pass it on to my partner, Ayman.
Thank you, Mohammed. So I'll be answering what is the best choice of electric vehicle based off of our data. Next slide. So we created a bar graph here. On the x-axis, we have the number of registrations, and on the y-axis, we have the EV model. And evidently, we can see that the Model Y outperforms, or the more popular choice out of the rest of them. And then these were just the top 10 most popular electric vehicles, since we had a little over 40 total, which we can fit on the bar graph. Yeah, next slide. And then what is the best choice of electric vehicle? Again, we still have the Model Y. X-axis, we have the average electric range, and it's justified why the Model Y would be the electric, the vehicle of choice. It has a little over 300 miles of range. Yeah, next slide. And we wanted to back this up by research. So I guess there are several reasons as to why Tesla is the most popular choice. The first is that they have a very comprehensive charging network. They have extremely fast supercharging, and the users can benefit from fast and reliable charging experiences, which are placed very strategically, specifically along like I-5, which goes north to south in Washington. The second thing is climate and geography. So Washington is very diverse in its weather. So people tend to prefer all-wheel drive cars, which is the Tesla Model Y, and also state incentives. The Model Y qualifies for a lot of the state incentives that Washington has to offer, and it also appeals to, not just individuals, but families. Next slide. So which type of EV is preferred, the plug-in hybrid or the battery electric? So based on our findings, we were able to determine that battery electric vehicle is significantly more preferred than hybrid, almost triple the number of registrations than hybrid. Next slide. And then the heat map that we created here basically determines your clean alternative fuel vehicle eligibility. So Washington has programs where you can get benefits for having electric vehicles. And as you can see, there are significantly more battery electric vehicles that are eligible for this than hybrid. Yeah, next slide. And then here are some pros and cons between the two. Zero emission mandates, Washington is also aligned with California in eliminating the sale of gas powered cars by 2035. So people tend to favor battery electric. They also have a much larger network of charging infrastructure. And, while plug-in hybrids can use these, their batteries are a lot smaller. So it makes people more, they would prefer to charge at home. And so plug-in hybrids they don't benefit as much from the charging network in Washington. And obviously battery electric vehicles have significantly more advanced technology than plug-in hybrids. Next slide.
Okay, thank you, Eamon. I'll be covering this question based on occurrence. Which cities, counties, and legislative districts are most likely to have the best EV charging infrastructure and policies? Next slide. So to start analyzing this question, we wanted to generate some sort of heat map to just get a visual going on where we can focus our analysis. We can see most of the vehicles are going to be in the darker red areas. We can see in the northeastern part of Washington, is a very dense area of electric vehicles, and there's also a dense area on the right side, on the eastern side, and on the south side. This is an interactive map that was created with the Folium Python library. We had to do a little bit more pre-processing for this, which took us, we had to separate the latitude and longitude values in order to input them into the library. For the purpose of this presentation, we're just going to show screenshots with more zoomed in screenshots on the following slides. Next slide. So as far as the cities, we can see on this bar graph, Seattle is by far the most, houses the most electric vehicles in comparison to the other cities. For this bar graph, we condensed it to the top 10 since we're trying to figure out the best areas for EVs, since there are many cities in Washington, obviously. We can see Seattle's the most, and followed by Bellevue, Redmond, and Tacoma. And we'll see that a lot of these cities are urban areas and they're condensed in pretty much the same general area. Next slide. We can see these two zoomed in screenshots here. Seattle, Bellevue, Redmond, Tacoma, and Bremerton are pretty much all next to each other. And then Vancouver is towards the south side of Washington, pretty much on the border of Oregon. But we can see that these are very densely urban areas. And yeah, next slide. For the county, we can see again a very standout county, which is the King County. This county has cities such as Seattle, Bellevue, Redmond, and Tacoma, which is what we mentioned earlier. This county by far has the most comprehensive charging infrastructure due to its urban nature, and has the cities that have the most are driving the most change for adoption for EVs, such as Seattle's Green New Deal, which is accelerating the spread of vehicle chargers in public and workplaces, along with implementing other incentives for EV owners. Next slide. This is our visualizations for the legislative district. A lot of this data is repetitive as it is all locational. For this, we can see it condensed to the top 10, just like the other bar graphs, because there are a lot of districts. And we can see half of the graph is populated with districts in the 40 region. And if we look at the district map, we can see that all of those regions, including District 11, District 1, are all pretty much in the same place, which is also where Seattle, Redmond, all those urban cities are located. We were hoping to see a little bit more of a correlation between the legislative districts and the EVs, given that we thought that legislative districts would have more of an influence on just EV adoption and incentives and policies, but we'll find in the next slide that it is more statewide. So next slide. We did some outside research that shows, the policies are more statewide, but they're focused on urban areas like King County. King County has a action plan that they enacted in 2020 that is aiming to replace most of its county fleet to electric vehicles by 2025 and 2030. And just recently, I think it was a couple months ago, they were granted $6 million from the state in order to expand their EV infrastructure. And like we saw in the data reflected, it is supported by the outside research as well that cities like Seattle and counties like King County are are the best places to live when you're owning an EV. Next slide.
Thanks, Miguel. Okay, now on to the challenges. A majority of the challenges came from the pre-processing because there were a lot of zeros or missing values in the dataset, specifically in the base MSRP and the electric range. While we were able to impute values for the electric range using like the average electric range for cars with the same make and model, we weren't necessarily able to do this for base MSRP because in our dataset, almost more than half of the values in the base MSRP were either zero or just straight up missing. And since uh, almost half of them were missing, we couldn't just impute values because they would just be really skewed, like with the averages or even medians, because it would just skew the data. So that's why we just completely removed base MSRP. And another thing was that I mentioned earlier was that some columns contained extra commas, which would uh, uh, make it hard to uh, work with our data set because we use the comma as our delimiter to split up columns. So we had to go through each column and look through where to remove these commas in order to get it down to the 17 columns that we need. And for analysis, one of the hardest parts was that a lot of our data was categorical. So it due to the lack of numerical data, couldn't make many meaningful conclusions. And there were a lot of redundant fields that just contain the same information, such as the vehicle location and Dayton County and even the postal code, because for example, the vehicle location, that field was just the latitude and longitude of the center of the postal code. So a lot of it was just redundant. Uh, that's all for challenges. Now I'm going to pass it off to Mohammed to finish us off.
All right, thank you, Ryan. Yeah, so if you had to summarize our entire presentation into just a few several sentences, these were our goals, these questions, and we found the answers to them. And so the Tesla Model Y is the best choice of electric vehicle based on occurrence, mainly due to its Tesla supercharging network. That's likely what plays the most important role, and also its range. And based on occurrence, battery-powered vehicles are far preferred over plug-in hybrids, as we saw earlier in the graph. And mandates, incentives, and growing charging infrastructure play an important role in that as well. And lastly, urban areas are typically the most preferred places to live when owning an EV, or EVs are most preferred to people in urban areas. There's a correlation there. As we saw, cities in King County like Seattle and Tacoma have the strongest charging infrastructure, so that's likely a reason. And also, EV incentives and policies are much more prevalent in those areas than random other cities that are outside urban areas. So, yeah, thank you guys so much for listening. Alrighty.